Let's solve the following equation. We have the cosine of x to the power 2021 plus cosine of x to the power 2022 plus cosine of x to the power 2023. All this sum is equal to 3. So this is an equation that we need to solve. If you try and solve this one with your calculator, it will take forever. Mine, I have TI-89, will take time, but it will give me some solution. I'm still waiting for the solution. I just want to compare that with the hand solution. Okay, in our case now, we have to solve this equation here, and an easy way or a suggested solution is that to let big X be the cosine X. Here, when we do this change of variable, we have to impose a condition on a big X. So big X is going to be between -1 and 1. Okay, because the cosine X, small x is in R, but the cosine takes values only between -1 and 1. Okay, so we have these conditions. Let's solve this equation. You can stop here, and with these hints, you can solve the problem. Okay, let's solve it together. Okay, so here we're going to use big X as the cosine of X with big X between -1 and 1. Okay, and small x is going to be in R. So here, when we do that, we're going to have this change x to the power 2021 plus x to the power 2022 plus x to the power 2023 equal 3. Okay, we see that 1 is a solution. Okay, so clearly 1 is a solution, and sometimes it's good to see that. Okay, it's good to see that because once we see that, we can see that we can factor a polynomial of degree 2023 and find the coefficients by identification. This might seem impossible, okay, but we can do something else. We can split these 3 into 3 ones. Okay, that's what we're going to do, and we'll take it to the left side. We're going to have x to the power 2021 minus 1 plus x to the power 2022 minus 1 plus x to the power 2023 minus 1 equals 0. Okay, now we use the fact that x to the power n, where n is an integer, we have x to the power n minus 1 can be written as x minus 1 times x to the power n minus 1 plus x to the power n minus 2 until 1. Okay, doing that, we're going to have here x minus 1 times x to the power 2020 plus x 2019 plus 1. For this one here, okay, we're going to have the same coefficient here. We use different colors. So the black is coming from this black here. The red is coming from this red here. So I'm going to have x to 2021 plus x to 2022 plus x 2019 plus 1. The green one is going to come from here. So I still have this coefficient x minus 1 is common to all of these because it's coming from here. So for the first one, n is 2021. For the second one, n is 2022. For the third one, n is 2023. So the green one, I'm going to have x to the power 2022 plus x to the power 2021 plus x to the power 2020 plus x to the power 2019, etc. until 1 equals 0. So therefore, I'm going to have x minus 1. Okay, if I sum up all these quantities, I'm going to have x to the power 2022 plus 2x to the power 2021 plus 3x to the power 2020 plus 3x to the power 2019 and plus 3. Okay, so now equals 0. We can prove that this is never 0. How are we going to do that? You're going to do that. Okay, this is a polynomial. So to prove that this one is never 0, we have x is between -1 and 1. Okay, prove that this one is never 0. Okay, x is between -1 and 1. It's very easy. Therefore, the only case one we have is that x minus 1 is 0, and therefore x is 1. This means that our x cosine x is 1. And this happens when x is 2k pi, with k is in C. Okay? So that means the solutions of these equations this equation is x is 0, x 2 pi, x 4 pi, or x is -2 pi, -4 pi, minus, etc. So you see the solution, the general solution is this one here, and this is the only one. Okay, so your task now is to prove that this one here is never 0. Because if this is never 0, this means that this one is 0, and therefore we get the solutions. Okay, thank you very much. If you see any errors or mistakes, please let me know. Thank you.